This video will look at question 27 from the 2017 exam. In this question, we are given a radioactive decay of an element X, which decays into a stable element Y, an alpha particle, and 3 beta minus particles. We also are given a list of A to H, that's 8 nuclides, with their respective atomic masses and atomic numbers, and we are supposed to say which one of these cannot be formed during this process. So here is a little reminder of the 3 types of radiation. Alpha is a helium nucleus, beta minus is an electron, beta plus is a positron, and gamma is a photon. But as it turns out, we don't actually really need that to solve this question. Note that I wrote the atomic number is the number of protons. And also remember that the number of neutrons in an atom, in the nucleus, is its mass minus the number of protons. So here is a new column where I subtracted the 2 numbers to get my number of neutrons. In the beginning, we only had element X, which had atomic mass m and the number of protons was q, so the original number of neutrons was p minus q. Now, could the number of neutrons have increased at any stage? No, it couldn't. We are not supplying any extra neutrons to the system or anything else other than the element X itself. You could still argue that a neutron could be somehow created in the reaction, maybe from a proton, which is possible. There is such a reaction called the inverse beta decay, where a proton is turned into a neutron. But as you can see, there are many other particles around which aren't in our equation. So it is impossible for the number of neutrons to have increased. And as you can see, one of the nuclides they gave us, namely A, does have an increased number of neutrons. That means that this one couldn't have been formed at any stage of this process, and hence A was the correct answer.